1-6, solving compound and absolute value inequalities. Let's take a look at a compound inequality. This consists of two inequalities joined by the word and or by the word or. Let's start with the word and. When we have the word and, what we want to do is we want to find the answers that are true to both of the inequalities. So in this case, x is greater or equal to -4, which is the graph here. X is less than 3, which is a graph here. And if we want x is greater or equal to -4 and x is less than 3, we want the values that are true to both. So we want the intersection, what is happening in both. Now notice that there's a kind of an in-between idea. So -4 is the least, and we're going all the way up to 3. Now in an and situation, we often write it this way. We start with the lowest value, and we say it has to be greater or equal to, so we reverse the sign here, x, but it has to be less than 3. So we have our lowest value, and then we have our highest value. Now notice that there is a closed circle on less than or equal, and there's an open circle on the less than. Now let's take a look at some examples. So we have this example. This is an and, where this expression is between 8 and 23. Method 1, you can solve them separately. You can just split it apart, solve both of them, and then pull them together. Most of us solve them both together. What we do is we treat this as like two sides. And what we're going to do is we're going to add 7 to both sides, add 7, and most of us don't even show the adding 7. We just do this in our head. 15 is less than 3y, less than or equal to 30. And then we're going to divide everything through by 3. And again, most of us don't actually show the dividing by 3. We actually just do this in our head. 5 is less than y, which is less than or equal to 10. So this answer right here is reflected right down here. This is our lowest value, and this is our highest value. We want all values between, and that's what an and will give you. Notice it's an open circle because of the less than, and it's a closed circle at 10 because of the less than or equal. Let's go ahead and do a problem again. So I'm going to subtract 8 on both sides. I'm showing you the subtracting 8. Most of the time I don't write this out. I just do it in my head. And so this is going to be -20 less than or equal to 4x, which is less than or equal to 24. Now I'm going to divide everything through by 4. Dividing by 4 does not change the inequality, so this is going to be -5 less than or equal to x, which is less than or equal to 6. So I'm going to have a closed circle at -5, a closed circle at 6, and I want all the values between. So this is between. This is typically what an and looks like. All right, here I'm going to add 2 to both sides, all 3 sides. And this is going to be -3 greater or equal to 3z, which is greater or equal to -12. And then this will be -1 greater or equal to z, which is greater or equal to -4. Now notice I didn't change the sign because I didn't divide or multiply by a negative number. So this is kind of awkward for me. I really like the lowest value here, -4 less than or equal to z, which is less than or equal to -1. So -1 is the greatest value in a full circle, and 4 is the least value, and all values between. All right, pause and do the problem. And here's the answer. Let's go ahead and work on or. Now, when we're working with or is true if one or more inequalities are true. One or more are true. So we're going to accept both of them. So here's an equation, inequality x is greater than 5. Here's one, x is less than -3. And we're going to do both of them being true. So we're just going to kind of put them together. And this is going to be an or statement. And an or statement has no other way to simplify it because it usually is in 2 different directions. One arrow will go to the right, one arrow will go to the left. Let's take a look at this or statement. What we want to do is we want to solve for this part right here, and then we want to solve this one. And once we solve them, we are going to graph both of them, and both those graphs will be the answer to the solution. So all the solutions will be this one, or meaning you're pulling them both together. Okay, so let's go ahead and do this problem. I am going to divide both sides by 5, so j is greater or equal to 3. Now notice I didn't change the inequality because I didn't divide by a negative number. But here I am going to divide by a negative number. Knowing I'm going to divide by a negative number, I'm going to have to change my inequality, and that'll be j is greater or equal to -7. I divided by -3 here and -3 here. So here's -7. It's going to be a full circle, and it's less than. And then over here, this is going to be a full circle filled in 3, and then so all of these values are the solution to this or inequality. I'm going to do this one. G is greater, and then I'm going to add 6 to both sides, -5, or 2g is less than -19, and then g is less than -19/2. So greater than -5, so that's circled, not filled in, greater than 5, and this is -9.5. -9.5 is right about here, and then these values will be less than that, and that's the solution to that or. Okay, pause and see what you can do, and here's the answer. Let's take a look at inequalities with absolute value. Now in this situation, the absolute value is less than 3. Whenever you see the word less than here, I want you to think and is always a in-between situation. So in other words, the distance between 0 and x has to be less than 3. The distance between 0 and 3 is less than, so we want all these values right here. And this is kind of a between value. A lot of times we write it this way. -3 is less than x, which is less than 3, and that helps us look at the graph correctly. Now in an or situation, this will be greater. So when you see greater than, think or. And what you're wanting to say is the distance between 0 and x is greater than 5, so you want all of these arrow values here, or less than or equal to -5, so that's these values here. So it's going to have two different graphs. Two different graphs can be written like this. So x is greater than -5, or -5 is greater than x. And a lot of us write it just x is less than -5, or x is greater than 5. We'll write it that way. Okay, so let's do some problems. Okay, I see less than, and when I see less than, I think the word and. So that's a between situation. So I know this is going to be t is going to be between two values, the distance 6, and it's going to go the other side of the distance 6 to -6. So this will be circled, not filled in, circled, not filled in, and all values between. Over here, absolute value of u is less than -3. Now remember, this is a positive value. A positive value can't be less than a negative value. So there is no solution to this. Now when I see a greater than, I think or. So I think t is going to be greater than the distance 3, or has to go in the opposite direction. T is less than -3. So I'm going to circle -3 and all values less than it. I'm going to circle 3 and all values greater than that. Now this says the absolute value is greater than -2. Remember, this is a positive value. Positive values are always greater than negative values. So this is all of the answers. Every answer here will work. So if you put in a -8 right in here, the absolute value of -8 is +8. 8 is greater than -2. So that's all real numbers. Your turn. Pause. And here's the answer. Pause. And here's the answer. Now let's take a look at absolute value inequalities, a little bit more complex. Now instead of just being a single number, it's going to be an expression here. Greater, I want you to always think or, and less than, I want you to always think the word and will always be this between situation. So when you see greater, set up an or. When you see a less than, you set this between situation up. So let me go ahead and do a problem. I see greater than, so I think or, And what I write is, I write 4x minus 7 is greater than 13, or I want to go in the opposite direction, less than equal to negative 13. Now I want to solve. 4x is greater than 20, x is greater than 5, or 4x is less than negative 10. I add 3 to both sides, so x is less than negative 10 fourths. So greater than 5, and this is negative 2.5. Negative 2.5 is right here, and I want less than. Okay, this is a less than, so I think and is always this between situation. So I write 5z plus 2 is between the distance 17. We're going to go over a distance of 17, and then we're going to go in the opposite direction, 17. I'm going to subtract 2 on both sides. Negative 19 is less than 5z, which is less than 15. Negative 19 fifths is less than z, which is less than 3. Notice I did not divide by a negative number, so I keep the less than symbol. So I want, these should have all been less than or equal to. So I want 3, and I want, this is negative 3 and 4 fifths, negative 3 and 4 fifths, so that's right about here. And filled in circle, and then we want all values between. Your turn, pause, and here's the answer. Pause to see where the error is.